Good morning, everyone. Today is Monday, May 24th, and we're going to be working on our Unit 7-8, page 11, stem and leaf and scatter plots. Our objective for today is to continue what we've been working on with dot plots, histograms, and box plots, but with two last representations called stem and leaf and scatter plots. So we're going to be creating some, interpreting some, and answering a bunch of practice questions today. Before we get started, go ahead and complete your DIN. We've got two box plots below, and we're going to compare those, and then we're going to go ahead and take a look at this stem and leaf plot, see if we can figure out what the median of that will be. So go ahead and pause here and then come back. All right. So hopefully you got your DIN done. We can compare the box plots shown below by just writing a couple of statements about what we notice. If you remember from Friday's lesson, we know that our minimum is represented by our sort of first line here, and our maximum is represented by our last line here. And so that kind of shows us the range. It looks like the range of data set S is much smaller than the range of data set T, if you're looking at that full length there. So we could have that in our comparison, okay? S's range is smaller. If we were looking at the medians, which is just this middle line, looks like data set S has a median of 44, data set T has a median of 43. So if you're comparing that way, data set S actually has the larger median. And then the very last one, interquartile ranges. That is the sort of box part of our box and whisker plot. So you're looking at our first quartile and our third quartile and comparing the size of that box. And so again, dataset T has the larger interquartile range, just like it did with the sort of regular range, okay? Any of those statements can be written here for your answer, comparing what we see on those two box plots. And so now we're looking at our new representation called a stem and leaf plot. And it's very, very simple once you sort of know what you're looking at. This is just another way to sort of create a list of data. Normally when we had our list, we had like 5, 12, 15, just sort of written out in a line of numbers. This just organizes it a little bit more, and we're going to see how that happens in just a second. But when you're looking for the median, you're always looking for the middle. So what you can do here, even though we don't quite know what our stem and leaves already are, we can still sort of use our fingers on the first number, which is actually the 2 in the leaf column, and the very last number, which is the 8 on the bottom of the leaf column. And we can keep going closer and closer to the middle until we find that median number, which for us should be, I believe, a 5. We'll come back to that example in our notes for today. It's going to be the same stem and leaf plot once we get a little bit of a better understanding of what we're looking at. So let's fill in some of our vocabulary first. Stem and leaf plots are a plot where each value is actually split into a stem, which is the first digit of that number, okay, and then the leaf, which is the last digits of that number. So, for example, this 32, instead of it being just represented in a normal regular list, they broke it by the stem and the leaf, and they placed it there, okay? The 15 we could see as well. The stem is 1, the leaf is 5. Same with the 16. The stem is 1 again, so it's going in that same group, and then you put the leaf as a 6, okay? All of these ones in the middle here have the same stem, which is 2. So again, they go in the same group, but you put each leaf separately. Okay. So we're going to try that with our list here. I'm going to go ahead and create some more space for myself and try to get this written down nice and neat. So I think I'm going to try and type it instead of drawing it. But our first job to do is sort of label, where our stems are going to go and where our leaves will go. There we go. The first stem we have is 1 from that 14. And then our leaf is a 4. Okay. The second number we have has the same stem, so we're going to leave it just like that. And then in our leaf column, you'll create that comma and put the 8. Okay, so you're basically just splitting each number into its digits. The third number has a different stem, so I'm going to press enter here, get that stem 2, and the leaf, which is also a 2. Third number has the same stem, so it's staying in the same group, but its leaf is 6. Then we have one with the leaf of 7. And then we're moving on to our next stem, which is 3. Okay. That one is a 3, so the leaf is 0. 31 has a leaf of 1. 35 has a leaf of 5. And 39 has a leaf of 9. To our 4s here, we've got 43 and then 48. 5s, we've got 51. We've got 2 53, so we do have to represent that twice, and a 54 and a 56. Our stem and leaf plot is complete. Okay. And so now that we sort of know what a stem and leaf plot is, how to look at that a little bit closer, we're going to go to exercise 2 and find the mean, median, mode, and range of this one. Okay. Mean is still the same thing as when we have a regular list. You have to add all of the numbers together and divide them by how many numbers there are. Okay. And I believe this is the trickiest part for a stem and leaf plot, because you have to remember that the 1 and the 2 are making a 12. Okay. The 1 and the 3 are making a 13. So when I'm starting to add these together, I'm going to use my calculator here. We have 12 plus 13 plus 20, because that's the 2 and 0, plus 21, plus 25, another 25, and then 28. Then we've got 34. Oops, I think I made a mistake here. Let me recheck. There we go. So plus our 34, plus our 36, plus 39. Then we're moving, they skipped the stem 4, so we don't have any numbers that are in the 40s. We're going down to 53. So we're going to add 53. And then we have 54 3 different times. So 54, 54, and a 54 again. And we have a 56. Okay, and you're going to keep on adding those until you have them all set and done. I'm going to do those one more time again really quickly, just so I'm making sure I don't have any mistakes. All right, plus 62 plus 65, 66, 67, and 68, 80, 83, 85, and 98 is the very last one. So Get a really, really large number there. I believe it should be 1,264. I could have made a small mistake with that, but I did check it a couple times, so I'm hoping that's correct for us. So we added up all of our digits, and now we have to count the total. So if that was a 12 and a 13, that's two numbers. 3, 4, 5, 6, 7 numbers, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, and so this is all for just our mean, which is the average, taking the total, divided by the number of values that you actually have, and we should get 50.56. Okay, that one's the hardest part. Now we're moving on to our medians, a little bit easier. We tried this one for the DIN, and now we want to double check to make sure we were correct. You're going to put your finger on the first number, which is that 12. So we're going to find the leaf of 2. On the last number, which is 98, using the leaf of 8. And you're going to keep going until we hit that middle value. I believe when we did this for our DIN, we got a 5, 4 or 5. And I think now we should be sort of in this range here. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I counted my 13th number is the middle. We have 25 total. And so our median is actually 4. It must have been a little bit off when we did this for our DIN. For the mode, we're finding which one is repeated the most. Okay, so our mean was the 50.56. Our median is 54. We just found that by finding the middle. Our mode is which one is repeated the most. And so we see all of these 4s here. That means 54 is the mode as well. And then our range. We said our smallest number is 12, but the biggest number is 98. So when we subtract those, we find our range, which should give us 86. Okay. I was sort of writing these on top of my words here just so we can keep them straight. Mean is the hardest to calculate. Then we've got our median, mode, and range. Okay. Let's move on to our very last type of representation, and then we're going to do some practice of both of these. We have something called a scatter plot. And it's a graph of plotted points that might seem really random. Okay, they could look anything from a straight line to just a bunch of random dots on a graph, but they're actually showing the relationship between two sets of data. Okay, and what we can do is find the correlation of that relationship. And so there's a bunch of different examples here with their correlations. If it is a perfect straight line and they are both increasing, for example, our Y value here, maybe they're talking about ice cream sales, right? And then our X value here, maybe they're talking about the temperature. Temperature increasing is getting hotter and hotter. So ice cream sales are also going higher and higher as more people buy them. That's a positive relationship. They're both increasing, which gives us a correlation of a +1. If we have something opposite, okay, and one value is increasing while the other one's actually decreasing, okay, going down, then we have a negative correlation. That is a perfect straight line, which would be a -1, okay? And then, like I said, they're not always a perfect straight line. A lot of the times they look like a bunch of random dots on a graph. And so you go from a strong relationship or a perfect relationship to a pretty high positive or a low positive. They're getting farther and farther apart. Or if you're directly in the middle, there's no correlation, has a very weak strength there. Or low negative and high negative, all the way to that perfect negative that we were talking about. Okay. So what we're going to do is practice drawing some scatter plots and then figuring out which correlation they have based on our sort of chart here. We have a table and they're telling us a bunch of different points to plot. So we're going to want to label our scale, see if we can do this pretty nicely and evenly here, plot our points, and then take a look at what kind of relationship it has. So I'm going to give myself a little bit more space, make this as big as I need to, and press enter down here so I have some space on the bottom as well. Maybe. Not giving me that space. Maybe if I try to move that up. Oh well, we'll deal with it. Okay. So we're looking at temperature in degrees. So the temperature is increasing from 40 all the way to 95. We're gonna have to figure out what to count by to reach that 95. And then my hot cocos here are sort of going up and down, but we see our biggest number is 13. So we're gonna figure out our scale of how to get that all the way to 13. Okay. That one should be pretty simple. We can start with our 0 and just sort of count by ones because we will have enough boxes to fit 13 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. And then, like we said, we have to go from 0 all the way to 95. And so I think we may have to sort of count by tens here. Let's see, 10, 20, 30, 40, 50. Yep, we may have to sort of do that. So let's do our best to fill in some of these numbers. If you don't have space to fill in all of them, remember that we can sort of skip those lines. You don't have to always label every single one. So maybe we sort of pretend we're counting by 20s instead by skipping those lines. There's 40, there's 60, there's 80, and 100. Okay, and of course those middle lines are all of the rest of the numbers that we missed. And then we're going to start plotting. So first point says 40 and 13. So we're going to try and find that 40 line on the x-axis here. I could even label that with an x, this one with a y, and then you're finding your 13 on the y-axis. Then we've got 64 and 4. And so here's where I kind of have to try my best to estimate things. If this is 64 and we know the next one is 70, sorry, if this is 60, the next one is 70. Halfway will be about 65. So we're going to go a little bit less than halfway to 64 and then up to 8. So doing my best, should be around there. We've got 69, 11, and 73, 7 for the next one. So now I'm getting really close to that 70 line and going up to 11, 69, 11, and then 73, 7. So again, I'm estimating my best about where they should go. There's our next one. And we've got 75, 5, and 82, 7. Okay. So let's see, 75, 5 is about here. 82, 7 is about here. And then we've got 3 more, 86, 3, 87, 1, and 95, 0. So 86, 3 should be about here. 87, 1, a little bit closer here. And 95, 0, all the way down at the bottom here. And so our last thing is to determine what kind of correlation this has. And so you're comparing it back to those sort of example ranges, okay? Does it go in a pretty straight line in the positive direction, or does it go in a pretty straight line in the negative direction? Is it a little bit more random, but still negative? Let's find out. I think our graph looks the most like this one. So we're going to say a high negative correlation. Okay, it's not exactly perfect, but I could draw a pretty straight line to sort of estimate these. Okay, I'm going to say high negative. I'll type that right at the top here. That is our correlation. And then we're good. So we have a couple more practice questions for you guys to try. We've got a stem and leaf plot where you find the mean, median, mode, and range again. If it makes it easier for you, you can bring this back to a regular list by writing out the numbers. So the first one would be 10, because it's 1 and 0, then 11, which is 1 and 1, another 11, and you could make that list first. Totally up to you. We've got a scatter plot, which looks a little bit crazy. So you're going to compare that back to our sort of chart here and figure out which correlation that is. And we've got another scatter plot that's already drawn for us that they're asking about the relationship for. So is it going to be positive, negative, or no correlation at all? And what do you think that means about the situation that's happening? We have an exit ticket where you create a stem and leaf plot on your own, and one last scatter plot to sort of label the correlation for. And then we have our self-reflection, and I think we're good to go for today. Bye, guys.